Good morning, everyone. Oops, where's my mic? Okay. So what are we doing today? We're doing homework 98. We're talking about the volume. I cannot get this right. Okay, I think that's good. Okay, so we're doing homework 98. And we're asked to find the volume of this solid, which I already graphed, is the rad x, square root of x, and x equal 4. So this is the region that we're going to find the volume of. This is the base. And there's three different ones we're going to do. Part A is a rectangle that's perpendicular, remember that's perpendicular, to the y-axis. And so let me focus on part A. If we're perpendicular to the y-axis, the base of the solid, of the rectangle, is going like this. The base is perpendicular, so it's going to form a right angle here. So this is the base. And in order to get this base, the distance from here to here, I need to go right minus the left. So the base is the right hand side, which is 4, minus the left hand side, which, by the way, I should have mentioned it earlier. If you're perpendicular to the y-axis, it has to be in dy. Has to be dy. So where this is x equal 4, this one should be x equal to y squared. So the base is right minus the left. And that is the base that I'm going to be using. So let me continue here. A rectangle. They tell me that the height of the rectangle is 3. So let me come over here. Because it's a rectangle, the area is equal to the base times the height, which is 3. I'm told the height was 3, and I figured out the base to be 4 minus y squared. So when we're asking you to get the volume, I'm going to integrate the area, dy. This is the area, base times height. And because I'm integrating in terms of y, looking at my graph, the y's are going from 0 to 2. So that's the setup. You can distribute into 3, make that a 12 and a 3y squared, or you could take out the 3 in front and then integrate. It doesn't matter. The setup is the big thing. That's a baby integral. We should all be able to get 16 as the volume. Part B. It's the same object, same shape. Now we have perpendicular to the x-axis, which means that I will be in the x, and it should be a square. So perpendicular to the x-axis goes this way, and this is the base that I'm going to have. This is the base. And to figure out that base, I'm going to do top minus the bottom. And x is, by the way, remember we're in dx. So the top is that function, rad x. The bottom is 0, so I'll write it, but just know that the base is simply rad x. And these are a square, and because it is a square, the area is the base, second power. And so that area is simply x. And the volume is equal to the integral of the area with a dx. integral of the area. That was the area of the square. And in terms of x's, looking at my graph, I'm going from 0 to 4. Okay, again, easy baby integral. You should be getting 8. That's the answer. All right, moving on, one more here. Part C, perpendicular to the y-axis, I will be in a dy. And so the shape here, the base goes this way. That's the base. And to calculate the base, I need to go right minus the left, like I did in part A. The right minus the left. And again, we're talking about a square, and because it is a square, I know the area of a square is base to the second power. Base to the second power. And so the volume is the integral of that, dy. And looking at my limits in terms of y, the limits in terms of y, I'm going from 0 to 2. Okay, I will let you integrate that. You got to expand that out. You got to square that binomial and then integrate. But either way, you should be getting as the final answer to be 256 over 50. All right, I'm going to do number 15. So to do number 15, I lost my calculator. Uh-oh. Wait, I found it. Calculator active, so just keep that in mind. We're going to need it. I already made a sketch of them. I graphed the two functions. Sorry, in the meantime, my phone is going off. Okay, I'll deal with that right now. So I have the graph, two of them. Y equal to negative cosine of x, which is the one down here. Is a cosine graph reflected, so it's starting from the bottom and going up. And the other one up here is y equal to the sine of x over 2. And they meet right there at pi. And the three choices, they're all perpendicular to the x-axis, all of them. And because they're all perpendicular to the x-axis, the base is going to be the same. Right there. So the base for all of them will be the top minus the bottom. The base would be that minus the bottom, the top minus the bottom. Now, I thought I had this earlier and I didn't, so I need to kind of catch up here. I think I cleared it because I wanted to enter those into my calculator. So I'm entering into my calculator the sine of x over 2 and the bottom one as negative cosine of x. So that when I integrate using my calculator, let me set it up first, it'll be a lot faster. So let's see, part A. The part A is a equilateral triangle. So for part A, because I have an equilateral triangle, I know that the area of the equilateral triangle is rad 3 over 4, the base squared. That is the area, and the base is what I have written up there. So the volume for part A in terms of x. And you know what? I'm gonna kind of give myself a little bit of space here. When I integrate in terms of x, I'm going from 0 to pi. I don't want to write the rad3 or a 4 inside of the radical or inside of the integral. I'm actually going to take it out because I'm going to pop that into my calculator right now. Save myself a little bit of time. And the base, the way I have it entered in my calculator, which one did I put first? Is the top one minus the bottom one. So I'm going to do y1, because that's where I put the first function, that's where I put the sign of x, minus y2, and I'm going to square that with a dy. Now, this is the setup, dx, sorry, and I'm going to show you in the calculator, because the calculator will do the work for me if I go math 9. Let me check that because I forgot the rad 3 divided by 4. Math 9 from 0 to pi. Now it has a parentheses there. I'm going to open up another one because when I go to y1 minus y2, I'm going to square that parentheses. You don't have to do that. You could actually enter the entire function there. I just think it's going to save me some time. And that's what I'm getting for part A. .783. Part B, I have an isosceles right triangle with one of the sides being down. So the area would be 1/2 the base squared. And so the volume then would be the integral of that. And you're going to see things very similar. Is the setup that's the important part. Now you have that 1/2 in the front. You still got to subtract the two functions and square them. Part C is isosceles right triangle with the hypotenuse down. The formula, 1/4 times the base squared. And so the difference now is that you have a 1/4 in front of the integral from 0 to pi, and the bases that I need to subtract those and square them. I keep putting dy, it should be a dx. So that is the setup for part B and part C. Pop those into the calculator. These should be your answers. 4, 5, 2. Okay. See you mañana.